Welcome back, everyone. Today's lecture is on Assignment 4, which covers Section 2.2, entitled Limits with Infinity. If you take a look at the graph that I've drawn, it's a part of a rational function. And as you learned in pre-calculus, one of the features of rational functions that we like to examine is that of horizontal asymptotes. And horizontal asymptotes describe the end behavior, and as a result we only draw those asymptotes at the ends. This graph indicates that the limit as x approaches positive or negative infinity for f of x is equal to b. And that is why we have drawn the asymptotes at the ends, only at the ends, of y equals b. In other words, as x gets very, very big out here, or as x gets very, very negative over there, the value of y, or f of x, is approaching b. One of my favorite functions looks rather simple. Y equals e to the 1 over x. However, each year, when I give this to my BC students to try to graph, it takes a little while and a lot of stumbling before they are usually able to come up with the graph. So what I'll suggest for you at this point is, after I finish speaking here, to press pause, take out a piece of paper, and see if you can figure out what this graph looks like. If we call it f of x, in particular you want to talk about what is the limit as x approaches positive and negative infinity for f of x, and also think about what happens at any other points of discontinuity. In particular, what happens at x equals 0. So I would suggest that you stop the video for a few minutes now and spend some time and see how well you can graph this function. So, a familiar note to you now, there's an important theorem in this section, in section 2.2, theorem 5, which lists all the properties of the limit of a function at infinity, and that's information that you should make sure that you are familiar with. As you also learned with rational functions, it's also possible for a function to have a vertical asymptote. And if we look at this function to the right, we see that there is a vertical asymptote at x equals 2. And here, as we did previously, we can talk about left-hand and right-hand limits. And in particular, the limit as x approaches 2 from the left of f of x can be written as positive infinity, and the limit as x approaches 2 from the right of f of x can be written as minus infinity. It's also correct to say that neither one of these limits exist, but when we say that a limit is equal to infinity, it gives us some sense of how the function is behaving. So that's it for today, and see you again tomorrow.